Hi, everyone. Today, I will talk about what is LAC hijacking API. This is my first time the session speaker, my first time the overseas conference, and my first time the overseas trip. So I'm a little nervous. My name is Kiyoshi Nomo. You can find me at Twitter at KYSNM. I am web application engineer and I am working at Goodpatch. I just joined November 1st. Goodpatch has a Taiwan office. Do you know Goodpatch? We provide a prototyping tool named Plot. If you are interested, please try out it. Today's agenda: the basics about the spec, about the implementation. Take a quick look at action cable. Conclusion. The basics. Who made this API? It was made by James Tucker, as known as at RAGGI, at January 5, 2013. Why it was made? As you know, LAC didn't have an API that allows for IO-like streaming. It is for WebSocket, HTTP2, and so on. Golang has an interface named Hijacker. It is a similar implementation. Probably this API would be made based on this interface. Support servers are Puma, Passenger, Shin, Webrick, and so on. About the spec. LAC hijacking API has a two modes: full hijacking and partial hijacking. The timing of full hijacking is request before status. The conditions of full hijacking, according to spec, if LAC hijack is true, then LAC.hijack must respond to call. LAC.hijack must return the IO. That will also be assigned, or it's already present in LAC.hijack_IO. LAC.hijack_IO must respond to read, write, read_non-block, write_non-block, flash, close, close_read, close_write, closed. Your responsibility of full hijacking: outputting any HTTP headers if applicable, closing the IO object when you no longer need it. In LAC-lint, the IO is checked through the hijack wrapper. In LAC-lint, full hijack is checked through the check_hijack. The timing of partial hijacking is response after headers. The conditions of partial hijacking: according to the spec, an application may set the special header LAC.hijack to an object that responds to call accepting an argument that conforms to the lag.hijack_IO protocol. Your responsibility of partial hijacking. Closing the socket when it's no longer needed. In lag-clean, partial hijack is checked through the check_hijack_response. About the implementation. I would introduce detailed implementation of the two servers. It is the WebRig and the Puma. WebRig. WebRig is supported only partial hijack. How to configure? See the test/spec_webrig.rb. In spec_webrig.rb, it is checked as support lag partial hijack. This as config.ru. Let's take a quick look at the behavior. First, self-run. App is lab config.ru. App is mounted to slash. Then server start. App is lapped from lag content length, lag common logger, and so on, like this. Accept the HTTP request, then WebRig calls the servlet.get_instance. Servlet instance invokes its own instance method service. Since lag handler WebRig inherits WebRig HTTP servlet abstract servlet, it calls lag handler WebRig initialize. Server is instance of the WebRig HTTP server. After prepare the environment variables, lag handler WebRig service takes out the IO_lambda. Prepare the read descriptor and the write descriptor using IO.pipe. Set the read descriptor response body, and then calls IO_lambda. It has passed write descriptor to arguments. The server returns the response, and at the end, lambda is processed synchronously. I tried the CURL on this laptop, but David displayed only 4 times, but it had been returned 5 times. You can see it at the trace log. Reason why maybe transfer encoding chunk. Please tell me if you know the reason. This is a demo. Left side server, right side client. Four times. The trace log shows 5 times. Next is Puma. Puma is threaded cluster-enabled server. supported two modes of hijacking. For hijacking example is in test/hijack.ru. As you can see, it is a procedure before Puma runner start underscore server, Puma CLI run, Puma launcher run, Puma single run. Puma runner start underscore server initialize Puma server. Puma server initialize prepares instance variables. App is, as you can see, lab hijack.ru. Puma single run invokes Puma server run. But when using cluster mode, it is invoked Puma cluster run instead of Puma single run. A Puma server run invokes a Puma server handle underscore servers. Puma server handle underscore servers initializes Puma client initializing. It has passed the I/O to arguments. When it is accept the HTTP request, this is the procedure before Puma thread pool spawn underscore thread, like this. Puma server run invokes Puma server process underscore client. Puma server process underscore client invokes Puma server handle underscore request. It is a little confusing, but Lick is an instance of the Puma client. Client is an instance of the I/O object. Lag.hijack is flagged, and an instance of Puma client has assigned to m.lag.hijack. So m.lag.hijack.call is Puma client call. At Puma client call, an instance variables hijacked of the Puma client is flagged, and an instance of the I/O object assigned to m.lag.hijack underscore I/O. By the way, constants is defined at PumaConf. At Puma server handle underscore request, hijack.ru is executed. At app is hijack.ru. And Puma client.hijacked is flagged. So return the async. This is a demo. I added 10 times and 3 for an example. Next partial hijack example is in test/hijack2.ru. Partial hijacking is the same as full hijacking until the app.call. It has passed m to arguments. But leak.hijack is false. Take out lambda from m.lag.hijack. The response underscore hijack is inbox. Argument client is the I/O. This is same as demo. Sorry. Take a quick look at action cable. In action cable connection stream, there is a command. This class is heavily based on Fei WebSocket. Action cable connection stream has a method hijack underscore lag underscore socket. As you can see, it uses full hijacking. Action cable connection stream has also a private method clean underscore lag underscore hijack. Fei lag stream has a similar method hijack underscore lag underscore socket. This method is a bit complicated. Continue. Until here. Fei lag stream has also method clean underscore lag underscore hijack, but not private. Conclusion. As you know, Action Cable has used the lag hijacking API. In limitation section at pull request, RAGGI says, I have not tried to spec out a full I/O API, and I'm not sure that we should. I have not tried to respec all of the HTTP / and HTTP semantics. There is no spec for buffering or the like. The intent is that this is an API to get out the way. In what section at pull request, RAGGI says, this is a strawman that addresses this within the confines of the lag 1.x spec. It's not an attempt to build out what I hope a 2.0 spec should be. But I am hoping that something like this will be enough to aid Railsforce ventures, enable WebSockets, and a few other strategies. With HTTP2 around the corner, we'll likely want to revisit the I/O API for 2.0. But we'll see how this plays out. Maybe I/O lab around channels will be okay. As he wished, Rail uses the lag hijacking API in Action Cable. I am looking for the future development. Thank you.